Hello everyone. My name is Chivi Prasanna Kumar. I'm doing my master's in civil engineering with project management specialization. Today in this presentation, I will sharing my thoughts and some facts about the space shuttle disaster and the events and the facts about this case. Yeah, thank you.
Hello everyone, I am Mohammad Hussein Hojjati and I'm studying mechanical engineering in master degrees. And today I'll be discussing the ethical dilemma in this case. Thank you.
Okay. Hi, I'm Mohammad Iftikhar Hossain. I am doing my master's in geometry engineering, and this is my second semester. And today I represent the presentation, and I will help my friend to present and
Uh,
present
my,
for me.
my name is Okotie Timitwaya, first year graduate student of mechanical engineering. I'm here, my group members talking on the case study of the events that went on during the crash of the space shuttle.
Hello everyone, my name is Gagandeep. I am a second year civil engineering student, and this is my third semester. And in this presentation, we are going to represent about the space shuttle disaster. And my friend Prasanna Kumar will give some will provide some information about the facts and the events in the next slide.
So here they are. So in this slide, I will share some thoughts and some facts about this event which took place in this case. So starting with the first event, we have Mission 51L payloads, which took place in late November with a series of changes in payloads. It also includes two satellites and a few equipments for the experiment purposes. And coming to the second event, it took place in January 27, 1985, which was crew assessment, where the NASA announced the name of the astronauts, which was assigned to the Mission 51L. Coming to the next event, it was like preparation for the flight, which includes several steps such as cargo integration review, a flight designation process, flight design process, flight planning and stowage review, and the training timeline. Coming to the fourth event, it is flight readiness review, in which it took place in January 15, 1986, and the main purpose was to confirm readiness of the flight preparation and the equipment, like where it is ready to go, whether we can uh, launch the rocket or not. But in this event, they didn't discuss about the solid rocket boosters, or they didn't review the O-ring and that part. So next event was orbital activity schedule, in which they discuss about what astronauts gonna do when they reach to the destination or to the moon. Like in day one, they arrival in the orbit. Day two, they will monitor the helicomet. Day three is Spartan preparation. Day four, closing of the Spartan, like that. They prepare the each and every schedule for the week. And the last event is about the launch delays. It was initially planned for January 22, 1986, but it was postponed three times due to the changes in schedule or Canadians' work requirements and unacceptable weather conditions. So coming to the next slide, I want to discuss few facts about this Challenger. This Challenger had a 9 successful mission before this disaster. So yeah, it is pretty much competitive, and yeah, uh, it was not that good. It is good like space shuttle. Coming to the next part, it is about the purpose of the Challenger mission. It was to launch those two satellites into the space in a single go. The third one is the Challenger didn't actually explode. It was actually Dr. Robin already discussed in the class that what is the O-ring and what is the about the O-ring design. It was to prevent the leakages, and it was actually collapsed and tore apart, which resulted in a flood of liquid oxygen and hydrogen. It created these two mixture created a huge fireball, and it was believed to be an explosion by many people. Yeah, coming to the next part, it is about the cold weather played its role. Like we all studied in the class that yeah, during the launch period, the temperature was below freezing point. So yeah, interestingly, based on the data from the past cold weather flights, they were NASA employees and the engineer were concerned about the shuttle safety, like whether we should postpone it or should we launch that or not. But yeah, that was not strong enough, so they went for it. So coming to the last part, it was about the crew members or the astronauts who were on board were like they were conscious, like when the leakage happened, they didn't died on spot. Like there was evidence back then that oxygen packs of the few astronauts were activated. So yeah, thank you. So next part will be continued by the Muhammad.
So I'm talking about the ethical conflicts at the heart of Space Shuttle Challenger disaster. Firstly, the main conflict, the core conflict in the Challenger disaster involved astronaut safety versus pressure to launch on a schedule. On January 28, 1986, NASA was set to launch the Challenger, but engineers responsible for the solid rocket boosters identified a serious risk. The O-rings crucial for sealing the boosters were at risk of failing due to unusually cold temperatures at Cape Canaveral. Engineers warned that the cold could compromise the O-rings' effectiveness, potentially leading to a disaster. So, what the engineers wanted? The engineers strongly urged a delay in the Challenger launch, fearing that the unusually cold temperatures could cause the O-rings to fail. So they recommended waiting for safer conditions to ensure the O-rings would perform properly, prioritizing safety over the pressure to maintain the launch schedule. But what management decided under pressure from NASA to stick to the schedule and avoid delays, management overruled the engineers' concerns and proceeded with the launch. Now let's look at the ethical challenge central to this disaster. The ethical dilemma in this Challenger disaster centered on the conflict between safety and a schedule. Engineers felt a moral and professional duty to delay the launch due to the serious risk posed by the cold temperatures. However, NASA and management, under pressure to avoid further delays and facing political and financial consequences, prioritized the schedule over safety, disregarding the engineers' concern. Finally, the outcome, ignoring the engineers' warning, led to the failure of the O-rings and the tragic disaster, unfortunately costing the lives of all the astronauts on board. The next part is about questions, which again we'll discuss about it. Thank you.
Thank you, Mohammed. So finally, in this slide, I'm going to represent you all three questions which our team think is good for the discussion. So these three questions are, the first question is, what are the ethical responsibility of the engineers when their professional judgment about the safety is overruled by the management? And the question number two is, what role does the effective communication play in preventing ethical failures in large and complex organizations like NASA? And the question number three is, how should organizations protect whistleblowers or individuals who raise their safety concern, especially when they conflict with organization rules? So in the next slide, I'm gonna talk about the question number one, ethical responsibility of the engineer. When an ethical responsibility of an engineer is overruled by the management, their first and the foremost priority is to always think about the public health and safety. No matter what happens, always have to think about the public health and safety. Engineers must escalate their concern and document them clearly, or if necessary, resort to whistleblowing if safety is compromised. And the last thing is deontology. It is basically an everyone, individual or engineers have to raise their voice about the right thing. So engineers have an absolute duty to protect the human life in any of the circumstances, even what happens in the society. So these are the some of the challenger disaster demonstrations. So I would like to mention here. So the disaster demonstrates the need of strong communication, whistleblower protection, and ethical leadership in order to ensure that the safety is not being compromised. So in the next slide, here are some of the references that we took in the next slide. And thank you very much, and thank you all.